Okay, so you can see on the board what we're going to talk about today. That's a lot of things. We would never cover this much if we weren't just reviewing, right, in one class period and one assignment. But a lot of the things a lot of this early stuff in particular is the basic review of basic math concepts, so we're going to go through them pretty quickly. I'm not going to write step 1, step 2, step 3 for you, though the textbook has some of those kind of steps for you, and you'll see it in the notes. I just did not put them in your syllable notes, all right? But you have access to that kind of stuff in the textbook in Canvas. We're going to talk about factors, time factorization, multiples, algebraic expressions, simplifying expressions, evaluating like terms, translating English phrase, a lot of things, right? We would never do this in one day. So it's going to be pretty quick. I'm trying to make it quick so you can get to your assignment less boring. That does not mean I don't want to answer your questions. I do expect somebody to have questions at some point. So when I say it's just a review, we're reviewing it for a reason, right? Everybody's not going to remember everything. If I expected everybody to remember all of this, we would not go over it, okay? I just don't know who remembers what. Give you a little bit of practice to refresh your memory, because it's basic stuff you use when you get to the more complex things, right? Okay, so we're going to go ahead and get started. All right. So most of the questions that I want you to fill in your notes have a red box. I might add a few things in the margin or around, and we'll ask you to do that as well. So multiples. So multiples of numbers. You can find the multiples of numbers just by counting by that number. So the multiples of 3, we're going to start counting by 3. So the multiples of 3 are 3, 6, 9, 12, 15. A multiple is the number that you're finding the multiples of is always the smallest multiple. So multiples are the numbers are multiples of themselves. Does that make sense? The 3 is a multiple of 3. Okay. All these bigger numbers in that row of multiples are divisible by 3. Okay. So we're talking about multiples, and we're talking about least common multiple and time factorization, and it's helpful to know what we're talking about. So we can say that a number is divisible by another number if you can divide it with no remainder. So one number can be divided by another with no remainder. That's what being divisible means. It's a little bit worded here, but if we're saying something is divisible, we're saying it's a number that can be divided by another with no remainder. Okay? There's some shortcuts here. Maybe you should have put these in your notes, but they are in the textbook on Canvas, right? So in order to do the prime factorization of bigger numbers, we need to know which numbers it's divisible by. We need to be able to find the multiples and such. So there's some shortcuts here. If the last digit is 0, 2, 4, 6, or 8, we know the number is divisible by 2, right? So if it's an even number, we call all those even numbers, right? If you can add the digits together and divide by 3 evenly, so if the sum of those digits is divisible by 3, then we know that number is divisible by 3. So for instance, 93, right? So 9 plus 3 is 12. Is 12 divisible by 3? So now we know that 3 is a multiple, or 93 is divisible by 3. Okay? 5 and 10 are pretty basic. I think most of us know those. For 5, if the number ends in a 5 or a 0, it's divisible by 5. If it ends in a 0, it is divisible by 10. Okay? It's a little bit more complicated. If the number is divisible by both 2 and 3, then we know it's divisible by 6. If it's only divisible by 2, or only divisible by 3 would not be divisible by 6. Okay? Any questions? All right. Is 5,000, you do have this on your paper, so I'll get rid of boxes here, so you're going to circle. Is 5625 divisible by 2? Actually, I'm going to put yes or no. Angel said no. Anybody else? Okay. It is not. It is not. A 5 is not one of those even numbers. Is it divisible by 3? Is it divisible by 3? Add up the digits and see that sum is divisible by 3. So 5 plus 6 plus 2 plus 5, 11, 13, 18. Is 18 divisible by 3? Sure is. It equals 6. Right? So yes, 5625 is divisible by 3. Is it divisible by 5? Yep. Is it divisible by 10? No. It has to end in a 0 to be divisible by 10. Is it divisible by 6? So it's divisible by 3, but not by 2. So we don't have to do anything. We know automatically, if we remember our shortcut, that it's not divisible by 6. Okay? Any questions? Factors. What operation are we using when we talk about factors? Addition, subtraction, multiplication, or division? Multiplication. Multiply. So numbers that are multiplied are factors. When you multiply two numbers together, you get a product, right? So a product is an answer to a multiplication problem. Prime number, composite number. Any no prime number, composite number, because we are going to have to do prime factorization. Prime number, accounting number. What's the first number in the accounting number? Do you guys know? Grant says 1. Grant's right. I taught it in 7th grade as when you teach babies count, you don't teach them to start counting with 0, right? We always start counting with 1, 0. Doesn't seem like it's super hard concept for babies and young kids. It's hard to explain nothing to them. They don't understand that concept. So counting number, but it's got to be greater than 1. So only factors of a prime number are 1 in itself. Is 7 a prime number? Yep. Is 9 a prime number? Trying to remember your name. What's coming yet? Aspen is not here. All right, tell me your name. Abel. Yes. Okay. Abel, is 9 a prime number? Yeah. Not a prime number. It makes it a composite number. Please. Except for the number 1. Number 1 is unique. It's not composite and it's not prime. Because in order for a number to be prime, it has to be greater than 1. So prime is pretty simple, but sometimes we get confused on whether or not prime is a number. So 1 is not prime, so if you would add that to your notes, there's no place for it. 1 is not prime, because 1 is not greater than 1. Prime factorization of a number means you're going to rewrite that number as a product of only prime numbers. So you're going to be writing a multiplication expression, and all of the numbers must be prime. And all the numbers that have no other factors besides 1 in themselves. Any questions? Henry? I think we're not there yet. So I think we're going left to right and then down left to right. So it's that way. This printing is weird sometimes, and they're along the order. But my goal is to do the top left to right and the bottom left to right. we got some of that. Perfect. Great question. That is one that we are going to spend a little more time on. So they do give you steps here. These steps in your textbook. I didn't put them in your notes, but you can go to Canvas if you want to do it step by step. First thing we're going to do is find two factors. It doesn't matter which two factors you find of this number. I usually just go ahead and start with making sure one of my factors is prime though, so I feel like that cuts out a step. So we're going to find, we're going to use basically what they call a factor tree. You guys remember it's kind of like a Christmas tree. Not really, but it's a triangle, so they call it a factor tree. It has branches, they say. So if I'm going to break this down into 2 times 24. I could have done 3 times 16, right? I could have done 6 times 8. I don't have any prime factors there yet, but that would be okay. We can just keep working down the ranges in the tree. So now 2 is prime, so I know when I come down, that 2's got to come down, but now I've got a factor of 24. So I'm going to break 24 down into 2 times 12. I could have done 4 times 6, right? 3 times 8, that would have been okay. More than one way to do this. One thing to make sure of, though, each of the rows, when you multiply them, they should all equal 48, right? So 2 and 2, we're bringing those 2 down. That range doesn't change there. Now we need to factor 12. So 2 and 6. I could have done 4 and 3 or 3 and 4. Didn't matter. I got 3 2's already. Those all stay because they're prime. That range doesn't change. And now I'm going to factor that to 2 times 3. So this is your answer, and it's usually acceptable for you to write it in exponential form. You could also write it as 2 to the 4th power. There's 1, 2, 3, 4 2's, right? So either of these would be acceptable. Does that help? We're going to do another one? We're going to do another one? Okay. There's probably more examples too in the book. All right, least common multiple. So I don't really know the prime factors method here. First period, I was just flipping through, trying to make sure I gave them enough time to start homework, and I started making a factor tree. But the easiest way to do this is we're looking for the least common multiple that these two numbers have in common. Common means the same, right? So if I list the multiples of 12, 24, 36, 48, 60. I'm going to stop there and see if that's enough, right? Starting with 18 now, I'm going to start writing its multiples. 18, 36, and I can stop at 36. I could keep going, but I don't need to, right, because they have 36 in common. So, least common multiple is 36. Any questions? Remember to find the multiples, start with that of a number, you start with that number and just count. You're doing it on a calculator, start with that number, multiply by 2, multiply by 3, multiply by 4, then multiply by 5, that will also be your multiples. Sometimes you have numbers that are easy to count by, sometimes you don't, so that's another way to do it if they're numbers that you're not comfortable counting by. All right, we're going to talk about variables. We use letters for variables that represent unknown values, and those values may change. We may plug in different values for that variable depending on the situation. The terminology, you should know the words that represent the operations, and I'm not going to go over that. I'm sure you guys are confident in that, but this table is in the textbook. The equality symbol. I think we know that. That's the equal sign. So inequalities that you may need a refresher on. I'm not going to read them to you. This is also in the textbook. Equal signs are lines here. Just means it's not equal to. This, once again, is in the textbook. I'm not going to read that. Grouping symbols, parentheses, brackets, and the curly ones are braces. When an expression is written with grouping symbols, if there's only one set of grouping symbols, it's usually the parentheses. Another grouping symbol that we use a lot is a fraction bar. I know we don't often think about it that way, but a fraction bar is also a grouping symbol. But if it's in the same numerator, denominator, we have multiple grouping symbols. We're going to have parentheses first, then the brackets, and the braces. On our calculator, if you didn't get a calculator, go ahead and get your calculator. We're going to put some things, some buttons on there. Did everybody get a calculator? So it's good turn. Okay. On your calculator, they only have parentheses. If you ever needed to enter something that had parentheses and brackets, just use two sets of parentheses and works fine. Okay? If you have parentheses, brackets, and braces, just use three sets of parentheses. It will do it for you. Now we are going to go over some order of operations. Your calculator will do the order of operations for you, but for today's assignment and on the test that we will take next week, I do want you to show me each step of the order of operations as you do it. After we get out of this unit, I would not make you do that more than likely very often at all. Okay, so all right, an expression. I think we have that on the next. So these are some translations from expression to words. 3 plus 5. We could also say the sum of 3 and 5. X over y, that's x divided by y, or the quotient of x and y. Remember, quotient is the answer to a division problem. Difference is the answer to a subtraction problem, or the operation of subtracting. All right, an equation is two expressions connected by an equal sign. It is not an equation if there is not an equal sign. Okay, guys? If you're asked to write an expression, don't put an equal sign. If you're asked to write an equation, you have to have an equal sign. So this little section, we are reviewing, converting, or translating from numerical equations to sentences, verbal expressions, or sentences. So you only are going to write the bottom one. These examples are in your textbook. But 3 plus 5 equals 8. So we can write that as the sum of 3 and 5 is equal to 8. Right? Could we have just said 3 plus 5 equals 8? Spelled out the word plus? We sure could. Right? We can go a bunch of ways verbally. Right? So there's only one way to go from a verbal expression to an algebraic equation. There's a bunch of ways to go from that equation, that mathematical sentence, to a verbal one. N minus 1 equals 14. 6 times 7 equals 42, or the product of 6 and 7 is equal to 42. When you translate, we do translate in the order that the numbers are given in the order of operations, basically. Actually, the order of operations not so much in order. X is equal to 63, I think you figured it out now. All right, this one is actually wrong on here. Can someone answer that one for me? Can you translate that for me? Marcus? For me? What is an operation? And you don't have to say, but because you don't always have to say that. Sometimes you will have to say that. Okay, so y plus 9 is equal to 2y. Look at this, 2y minus 3. That's the list is right there. We're going to make sure we put 2 times y minus 3. times y minus 3. Craziness. On the bottom down here, exponential notation. We can say numbers are powers or they're written in exponential notation. If it has an exponent, it's written in exponential notation. If it has an exponent, we can call the entire expression a power. So 2 to the third power is an exponential notation. The entire thing is also a power. Exponent also just exponent to be called a power. Okay. What does 2 to the third power mean? It means we're going to take that number and multiply it by itself this number of times. If you receive a to n power, it means we're taking whatever a is and we're multiplying it 10 times. So whatever number we want to plug in for n. Or I'm going to uncover this and let you write it. Let you identify the base. You're not going to really be able to read it. I'm going to write it over here on the side for us too. Worry. So if you've got a to n power, so you can write for me, this is the base, and this is the exponent, or the power. You can call it either. The entire thing is written in exponential notation. The entire thing can also be called a power. If we write a to the n power, what does that mean? That means we take that a and we multiply it by itself however many times n is. So these are the factors. So this a to the third power, if we evaluate for n equals 3, it'd be a to the third power, right? So we'd have a 3 times. So we brought it or a factor 3 times. All right. Expression. We got the next one. An expression, we talked about what it is not, but an expression is a number of variables or a combination of numbers and variables with operation symbols. So 3 is an expression. 3y is an expression. 3 plus x is an expression. This is the order of operations broken down for you here. Please excuse my dear Aunt Sally, how we remembered it when we were first taught it. One of the things you should remember is the multiplication and division always comes before addition and subtraction. The multiplication is not always first, right? It's from left to right. Addition and subtraction comes last, but it is also left to right. If the subtraction symbol is first, we subtract before we add. So it goes left to right, like you're reading a book. So the prime factorization and the order of operation problems are the ones that I'm mostly concerned about you showing some work for. Wow, that was fast. Okay, so we're going to do a couple of examples. My examples will not only remind you the order of operations, but I'll show you how detailed I'd like your work for just this section and this test on this section. So what are we going to do first here? Remember this said parentheses, so whatever it is, parentheses are grouping symbols first, then exponents, then multiplication, division, then addition, subtraction. Right, so what are we going to do first in this example? I'm trying to call somebody's name that I can't remember so I can practice calling your name. Full disclosure. What I'm about to do. If I can find my screenshot. about these? What do we do first? Perfect. So we're just going to rewrite everything out. So we've simplified 5 minus 2. What are we going to do next, Leo? Yep. Oh, wait. Are we going to? Let's see. We're going to do this grouping symbol here first, right? We're going to do that 12. That is multiplication, so those wouldn't matter around that, but technically we would concentrate on those parentheses first. All right? As long as you didn't add first, you'd be okay. Division and addition, we're going to do division, and now we're down to the addition. So step by step is what I want for this. That's what I want for the test on this. You must practice, so you get credit for the practice problem and then get credit for it on the test. And this next example has got parentheses and brackets. We're going to do the innermost parentheses first. So 4 minus 2 is just 2. Then we're going to do the multiplication within this set of grouping symbols to brackets. Then we have to do the subtraction within there. And we all know that 3 times 0 is 0, but that's the next step. Now, finally, we're through with all the grouping symbol expressions or terms. So now we can do the exponent. And this brings me to, I want to remind you how to use the exponent button on this calculator. So the exponent button on the calculator is the caret. And it is right below the pi button on the left side of your calculator. So if you put in 2 caret 3, like you're typing on a keyboard, that's how you do it on a keyboard, it's going to simplify to 8. And then last but not least, we're going to add this expression, simplify to 13. Any questions? All right, what does it mean to evaluate expressions? So if we evaluate with x equals 4, if we evaluate the expression x squared, what are we going to do with that 4? Bernella, what do you mean to evaluate something? If we have x squared and it says to evaluate with x equals 4, what do you think, Tiana? Plug it in. That's the expression I'm looking for. Sorry, Diana, I caught you. I know you. You're not the first person that walked out of the room. My way of work. Some people will trick me, but I will tell you, I usually catch everybody. Pretty good at it. And most people just forget. All right, so let's go ahead and make a note. I don't have a link for evaluating the plug-in. So they want me to evaluate x squared with x equals 4. Everywhere there's an x not expression, I'm going to put a 4. So 4 squared, x replaced with 4, simplified to 16. 3 to the x power. So the variable x is the exponent in that exponential notation. We're going to replace the x with 4. 3 to the 4th power. Remember, if you're entering it on your calculator, it's 3 caret 4. You should get 81. 2 times x squared plus 3 times x plus 8. So this one has more than one x. Everywhere there's an x, you replace it with a 4. if you're evaluating, let's say it's okay, you don't have to show me all your order of operations steps. You can just enter this left or right on your calculator. I'm not sure if you can use percentage multiplication on this one. One of them that I teach, you can. I'm sorry, you're saying. Yeah, you can just put parentheses in there. We should know this multiplication, but you can just put parentheses, enter it left or right on your calculator. You should get 50. All right. Any questions? Everybody caught up with me? A term. Remember, a term is part of an algebraic expression or equation separated by addition or subtraction. It can have multiplication or division within the term. The coefficient is the number being multiplied by the variable in a variable term, right? So here, 2 is the coefficient on x squared. 2 squared is the term. Sound familiar? Only like terms can be combined. They're all like terms. X and 2x, those are like terms. X squared and 2x, not like terms, right? Not only does the variable have to be the same, but the exponent has to be the same too. So when we are combining like terms, we just add the coefficient. So I like to start highest degree, lowest degree when I'm doing it. So I'm going to look in here, x squared, this is a degree of 2. I'm going to do all this x squared. So 2x squared is x squared. What's the coefficient of x squared? 1, yeah. So 2x squared and x squared, when combine those are 3x squared. They are like terms. 3x, can I add 3x plus 7? Jewel, can I add 3x plus 7? If I had plugged in or I were evaluating, I could, right? It would be 3 times whatever x is. So the other like term so I'm going to mark these out. When I'm doing multiple things, I usually scratch them out. Now I'm going to do my x term, 3x and 4x. Since those are both positive, I'm just adding 3 and 4. And my second term is 7x. And my constants, the terms with no variables, are all I have left. Let's do those. 7 and 5, add those together, and they equal 12. Penelope? No, there's not really. I mean, I'd like to see you're scratching them out or underlining them, but I'm not going to get crazy about that. I will tell you while we're thinking about it, I do want you to show work for all 7 through 18. And 19 through 30, those are the order of operation ones, so I do want you to show me work for all those. I do need to see what you plug in. So for like number 31, this x to the 6th power, I do want to see that you replace the x with 2, but then you can just use your calculator after that. Does that make sense? Yeah, the combining like term that I'm giving you work for. Yeah, I think that's about it for work. Okay. Little chart here with some terminology. One way you can translate the operation of addition, subtraction, multiplication, division, or several ways. I'm not going to read this to you. You guys have seen it before. This table is in the textbook. We're just going to go through and translate real quick. The difference means we're going to do what? Add, subtract, multiply, or divide. Add, subtract, multiply, or divide then. Okay. So the difference of 14x and 9. 14x minus 9. Quotient, what are we doing here? Add, subtract, multiply, or divide, Mariah? Yes. And they use a division symbol, but you guys know by now we typically would use a fraction bar for that. So 8y squared over 3 would probably be what we would use. 12 more than y. So this is a bit of a tricky word. More than implies we had something to start with, and now we have more of it, right? So let's remember that than means we're going to reverse the order or flip it, or however you like to say it. That means we're going to flip the order. So we can't say 12 plus y, even though 12 plus y and y plus 12, technically if we were to evaluate that expression for a given value, they would be equivalent. That is not what they asked us to do. If we're translating it, I have to put it in the correct order. 7 less than 49x squared. Now, if you put 7 minus 49x squared, that would be incorrect if you were to evaluate for a given value. We are going to translate it the correct way. A and B down here, this little exercise to show you the value of the parentheses, putting the parentheses in the correct spot. 8 times the sum of x and y. So we're going to add x and y first, then multiply by 8. So that order of operations is represented with those parentheses in the correct spot. Sum comes after 8 times here, so we had to put the parentheses there in order for that to be correct. Now the sum of 8 times x and y, sum is before that 8 times x, that is just 8x plus y. Mr. Zimmerman. Hey. Second, please. I'm lecturing. Can you come back? You can talk this way. Mr. Zimmerman's got nothing to do. Question. Can you right now, Mr. Zimmerman? All right, and this exercise here, let's remind ourselves when we put an equal sign and when we do not. Judy has dimes and quarters in her purse. The number of dimes is 7 less than 4 times the number of quarters. Less than, we're translating, we're going to switch some order around. Let Q represent the number of quarters. So dimes are 7 less than 4 times the quarters. We're going to write an expression. What's that expression going to be? Can you tell me, Hudson? So Q represents the number of quarters. What does it tell us about the dimes? Yep. How would we write that as an expression? Okay, 4Q minus 7 is correct, but this one's an expression. Does it have an equal sign? Okay, that's really the point I'm making. I do need you to be able to translate it, but if it asks for an expression, we're not going to have that D equals. This is the exact same question, but here you were asked to write an equal sign, and I don't know what that answer is there. It's not correct. So we're going to say D equals 4Q minus 7. Cool? Okay. I know we don't have a lot of time, but I would like for you to go ahead and start your homework. Remember 1 through 18 all, 19 through 53 odd. Remember which ones you need to show work for. Scan and submit if you know how tonight. If you do not know how, or you just don't get around to it, it won't matter tomorrow. We'll scan and submit them together for anybody who didn't do it or doesn't know how to do it.
I would like for you to have the Canvas app downloaded to your phone, though, okay? When you get here, Henry. Not today. No, we are on a trial period now. We won't listen to music on days we have notes anyway. Maybe straight solid review days, we might do that. So we're definitely not doing it until then. And like I said, it just depends on how everybody does in my 2 sections of Algebra 2. Not even considering that for my geometry. Jewel?